Alright, welcome back. This next example is another distance problem, and it's, if you will say, a distance problem maybe on steroids. We read here, Toronto's Pearson International Airport has a high-speed version of a moving walkway. So in other words, those are like an escalator that's flat. You can walk on, step on, and then it'll just stand still and it'll move you, or you can step on it and walk, and it helps you get to someplace quicker. So in this particular one, Liam, if he decides to walk while he's riding the moving walkway, is able to travel a distance of 280 meters in 60 seconds less time than if he chose to stand still. Okay. And we're also told that Liam walks at a rate of 1.5 meters per second. We want to find the speed of the walkway. Yes, I can see the answers, 2 meters per second, but let's work it out to see how we actually get there. So once again, we're dealing with distances. He's traveling the same distance two different ways. Standing still on letting the walkway do all the work, and then also walking along with it. And what we know is it takes 60 seconds less time if he walks than if he just stood still. So here's our chart. Distance equals rate times time. And we can label that as standing on the walkway and walking on the walkway. And then what we know is this. Let's put down the pieces of information that we actually do know. Okay. If we let R be the speed of the walkway, which is the thing we are trying to find, here, then standing, his speed would just be the speed of the walkway, R. If he was walking at his rate of 1.5 meters per second, then his speed would be 1.5 plus R. Now before I go any further here, you could have also set this problem up with time as your variable, because you know that it took 60 seconds less time. So you could have let one of the times be t, and then the other one would either be t minus 60 or t plus 60, depending on how you set it up. Okay. But I chose to go with the rate because that's what we wanted. What we also know here is that the distance both ways is 280 meters. Now, just like we did in the previous problem here, I'm going to solve to get expressions for time. Okay, so taking both of those equations and solving for time, you get 280 over r and then 280 over r plus 5. Now the relationship with time is what we're now going to use. Okay, it takes 60 seconds less time if he walks than if he stands still. So the time walking will be the time standing still, take away 60. And we're already in units of seconds because the rates that we were given were in speeds of meters per second. So our time would be in terms of units of seconds, so we're good to go there. Okay, so we write down time walking will be 280 over r plus 1.5. Then we put in the time standing, 280 over r minus 60. At this point we have a fractional equation. Well, remember, fractional equations, we can simplify those by multiplying through by our common denominator. In this case, it would be the two denominators. So we're going to multiply through by r plus 1.5. We're going to do that to each term. So when we come to the first term there, the first term right there, 280 over r plus 1.5. All right, we're going to multiply through, and then the r plus 1.5 will cancel out, so that we get just 280r. Then we go to our second term there, 280 over r times our common denominator. The r's will cancel out, and so we'll just have 280 times r plus 1.5, and then don't forget, then also multiply your common denominator times 60. That will give us minus 60r times r plus 1.5. Okay, so at this point we're going to have most likely a quadratic or a polynomial equation. So what we need to do is simplify. So we multiply through. So first we'll just have 280r, and then when we multiply through by 280, we'll get 280r plus 420, and then we're going to multiply through by 60r. So minus 60r squared, and then 60r times 1.5 will be minus 90r. Now, one quick thing to note, I have a 280r on both sides, so I'm just going to wipe that out. It's gone. At that point, I have a polynomial equation, so I don't like the squared term here, having a negative sign, so I'm actually going to move everything that's left over to the left-hand side of the equation. That would give me 60r squared plus 90r minus 420 equals 0. You can start with the equation the way it is right now. I'm going to clean it up some by realizing I can take 30 out of everything. That gets me down to 2r squared plus 3r minus 14. Now at this point you want to solve that equation, so my advice would be pause the video, either use your quadratic formula or do it by factoring. When you do, you will get two answers for r. r equals 2 and r equals negative 7/2. Obviously the walkway is not going backwards. It's helping him get there quicker. And so r equals 2 would be the speed of the walkway.